Hello, algebra. I hope you're well. This week we're going to finally talk about imaginary numbers and complex numbers. And I want to talk a little bit about real numbers before we get into what's an imaginary number. So real numbers we've been using all semester, and as we go on in mathematics, whenever we have a gap, we kind of try to invent something to fill it up. So the first kind of real numbers that we talked about and that we use are natural numbers. If you think way back to grade school, these are numbers that you were first introduced to. 1, 2, 3, 4, 5, ... going on forever into infinity. So these numbers are not fractions, they're whole, they're sometimes called counting numbers. And when I have numbers like this, I can add. So, question, what can be done with natural numbers? The answer is I can add. Right? I can say 2 plus 3 gives me 5. That's a nice thing I can do. But subtraction is a problem, right? What if I did 2 subtract 3? That answer would give me -1. And that's not a natural number. I don't even have to worry about negatives. What if I did 3 subtract 3? That would give me 0. That's not a natural number either. So then there's two different kinds of numbers that can address that problem. So whole numbers save us from this issue, 3 minus 3. And whole numbers, we just add 0 in. So notice these 1, 2, 3, 4, 5, ... into infinity. Those are all natural numbers. When I have a whole number, the only thing I'm adding is just adding in the 0. Now I can say 3 minus 3 is equal to 0. That's fine. But I still can't do something like 2 minus 3. That would be -1. And that's not a whole number. But no sweat. We've got more numbers out here that can solve this problem for us. We have integers. So integers, we add negative numbers into this. -3, -2, -1, 0, 1, 2, 3, ... And now I have these two ... This one's saying keep going to negative infinity, and this one's saying keep going to positive infinity. So now we can add and subtract. We can even multiply. And multiply. Right? If I take 2 times 3, gives me 6. Now I can take 2 subtract 3, that gives me -1, no problem. Right? But we do have a problem. Division is an issue. So if I wanted to divide some numbers, 4 divided by 2, that would give me 2, and that would be okay. But 2 divided by 4, that would be the fraction 2 over 4. And that would be 1/2. This is not an integer. And so we need another kind of number, right? We need rational numbers. And rational numbers are any repeating decimal So you've seen something like that, like 0.3 bar. There any terminating decimal? So something terminating means it ends, like 0.25. And there are also any fraction whose numerator and denominator are integers. But of course, 0 is not the denominator. Because you can't divide by 0. So a fraction, 0.3, you can actually write that as a fraction 1/3. And 0.25, you can write that as 1/4. So those are both fractions. You could also have 7/8, 19/23, any type of fraction like that. So those are all the kinds of numbers that we've been working with so far throughout this semester. We've had natural numbers, just a recap of what we've got. And that's 1, 2, 3. We have whole numbers. I just add the 0 in, and then 1, 2, 3, ... We have integers. And then now we have infinity in 2 directions. In the positive direction and in the negative direction. And we have rational numbers. So fractions and some decimals. We've also seen some irrational numbers. These are numbers like pi, square root of 3, the number e, which we'll talk about more. These are the other decimals. They do not terminate, they don't end. And they do not repeat. So today we're going to talk about a new kind of number. We're going to talk about imaginary numbers today. People freak out at this word imaginary. And they say if it's an imaginary number, it's not real, and that means I don't want to know about it. This is just the name of the number. I have good news or bad news for you, depending on how you look at it, but all numbers are made up. Can you point to 2? In the real world? No. But 2 is a concept that helps us understand the world. Like 2 cups, $2. to feet, right? Those are things that the number 2 helps us understand. And I is very, very similar, right? You can't point to I of something, but as a concept, it's going to help us. So let's take a look at the problem that I is going to help us with. So let's think about square roots. We spent a lot of time on this in class, so I'm hoping when I tell you that the square root of 4 equals 2, you're going to say, of course it is, Sarah, because that means 2 times itself gives me 4. Now, if I just have real numbers, I have a pickle when I get the square root of negative 4. This presents a problem for us, because the only way that I can get this negative sign here is when I multiply a positive times a negative. So I could do negative 2 times 2, or I could do 2 times negative 2. And those would each give me negative 4 as an answer. But then I don't have negative 2 times itself. I have negative 2 times positive 2. Those are both different. They're different numbers. So the square root of negative 4 doesn't have an answer until we introduce I. Introducing I. So I is the number that's going to help us handle that square root of negative 4. The square root of negative 1 is defined to be I by definition. So that means that I squared is equal to negative 1. And this is going to help us. Here's our example. We were worried about the square root of negative 4. Now we can address this. We can use our properties of square roots to help us. So I look at this as negative 1 times 4. And then I'm going to use my product rule for square roots to break it up like this. And then I'm going to use my definition. What is the square root of negative 1? We defined it right here. We said, by definition, the square root of negative 1, we're going to name that number. We're going to call that number I. So here is our number, I. And then now we have the square root of 4, which is 2. And when you're writing numbers like this, you always put the real part. This is a real number, 2. You put it before the imaginary number. So you would write this as 2I. And we know this is true because if I take 2I and I square it like this, I use my rule of exponents here. This exponent of 2 is applying to the 2, and it's applying to the I. 2 squared gives me 4. But what about I squared? Don't worry, we defined it. We said by definition, I squared is equal to negative 1. It's another name for negative 1. So this I squared here gives me negative 1. And then I have 4 times negative 1, and that gives me negative 4. Great. So now I can say negative numbers have square roots. That's exciting, right? I'm excited. I hope you're excited. So that is the imaginary number I. So I is another name for the square root of negative 1. And I squared equals negative 1. And that's an imaginary number. Now I want to talk to you about complex numbers. Don't worry. I'm just going to define them for you here, and we're going to worry about what to do with them in the next few videos. So here we have complex numbers. So a complex number is the sum of a real number and an imaginary number. And I'll give you some examples. So here are some examples. I could say 2 plus 2i is a complex number. Here's a real part. And here's an imaginary part. This is the imaginary part because it has the I here, that square root of -1. And this over here is the real part because this is a real number, because 2 is a real number. And so I could do that with any set of numbers that I like. I could say pi plus I. I could say 17 minus 3i. I could say 0 plus 2i is a complex number. Or I could say 4 plus 0i is a complex number. I could say 8 minus 2i. I could use fractions if I like. I could say 1 plus 1/2 I. And then let me go through. So this would be the real part. 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 And then the imaginary part, the part containing I. So that would be the imaginary part. And so these are all complex numbers. So another way that we write complex numbers is we say it's a number A plus B times I, where A and B are real numbers. So notice everything that I highlighted in red here, we would call our A. And everything I highlighted in yellow, we would call the B. So those are complex numbers and imaginary numbers. And I'm going to give you a couple of examples of how to write some imaginary numbers. So let's write these numbers in what we call standard form. Because you're used to already saying that we don't put a negative sign underneath a radical, and that's what it means to write it in standard form, is that we get that negative sign out. So let's try it. Let's write these numbers in standard form. So I would like you to give this a shot before you watch me do it. So pause the video and see if you can write these numbers using I. That's what we call it in standard form. All right, welcome back. So let me show you how I do this. So I look at this as the product of 9 and -1. Then I use my product rule of square roots to separate it like this. The square root of 9 becomes 3. The square root of -1 is I. So this would be the final answer. 2 is not a perfect square. But that's okay, we know what to do. I'm going to look for some factors of 24 to see if I can find a perfect square. So I see that 4 times 6. So I'm going to look at this as the square root of 4 times the square root of 6 times the square root of -1. So the square root of 4 gives me 2. Square root of 6 can't be simplified, and the square root of -1 gives me I. So I told you before that we put the I right after the numeric part, but in a case where we still have that square root, we typically rewrite it underneath here, and so we write it in this form, 2I square root 6. And we do that because we don't want it to seem like this I is underneath the